Today we are going to solve an amazing question, chemistry question on electron configuration. Without wasting my time, let's take a look at the question. Consider the following box diagrams for the ground state of nitrogen. Indicate the correct one and the incorrect ones. Identify the principle or rule which has been violated in each case. So this is for the incorrect ones. Okay. So first of all, we have to know the three main rules used in filling orbitals. The AUF-Bow principle states that electrons fill fully orbitals of lower energy first before they fill orbitals of higher energy. So this is in simple terms for understanding. Yeah, meaning if I'm closer to the nucleus, I should be filled earlier. Let me say it that way. Filled fully before orbitals of higher energy are filled. Also, Pauli's exclusion principle states that no two electrons can have the same set with the four quantum numbers. So even if they have the same principal quantum number, angular momentum quantum number, magnetic quantum number, at least there will be a difference in a spin quantum number, plus half or minus half. So there's never an occurrence where two electrons can have the same set of the four quantum numbers. Answer of maximum multiplicity states that degenerate orbitals are first filled singly with parallel spins before pairing up with opposite spins begins. So now we know these three. So anytime we see any of them, we can use these three to identify whether they are filled correctly or wrongly. So let's look at it. Let's solve it. Let's make some observations. So we are going to mark them one by one. Okay. So for I, let's see whether it obeys the Aufbau principle. Aufbau principle. Let's determine whether it obeys the Aufbau principle. So you can see that 2s is not filled before 1s. Yeah. 1s is filled fully before 2s is filled. And that's the case for 2p2. So 2s is filled fully before 2p2. So we can see AUF rule is followed. Correct. We are done. Now for Pauli exclusion principle, you can see that since they have the same set of the four quantum numbers, they have opposite spins, right? So we can see the same spin in the same orbital. So we can say that the Pauli exclusion principle is also obeyed. Now let's look at Hund's rule of maximum multiplicity. It says that degenerate orbitals are first filled singly with parallel spins before pairing up with opposite spins begins. But in the 2p orbital, which has three degenerate orbitals, 2px, 2py, and 2pz, you can see that in the 2px orbital, this orbital is filled fully with opposite spins, right? So you see, it should have been filled singly with parallel spins first, one, like this. So we can see that it doesn't obey Hund's rule of maximum multiplicity. Therefore, I is not correct. I is not correct. Why isn't it correct? It violates Hund's rule of maximum multiplicity. So I violates Hund's rule of maximum multiplicity. Therefore, it's incorrect. Okay, now let's look at II. Let's look at II. What can we see here? So for II, obviously, it obeys AUF-Bow's principle since the lower energy orbitals are first filled fully. Also obeys Pauli's exclusion principle. What about Hund's rule of maximum multiplicity? So you can clearly see that third field parallel spins singly before pairing up with opposite spins begins. So here, even there are no even opposite spins because there are only three, electrons going into the 2p orbital. So it will be 111. Yeah, 2px1, 2py1, 2pz1. So it obeys Hund's rule of maximum multiplicity. Then we can say II is correct. II is correct. Very good. Now let's look at I, I, I. Hey, I. Yeah. So what do we see here? For I, Pauli's exclusion principle is obeyed. Correct. AUF Bell's principle. Is it obeyed? No, because orbitals of lower energy are first filled fully. So you see, the 2p orbital was filled before the 2s orbital was filled fully. You can see that nothing is here. It should have been there. So it should have been filled fully with an opposite spin. So we can see it doesn't obey the AUF Bow principle, but it obeys the Hund's rule of maximum multiplicity. Because you can see that it was first filled with parallel spins 111 before this opposite spin came there. So it obeys the Hund's rule of maximum multiplicity. But since it doesn't obey the AUF Bow principle, it is incorrect. Okay, now for IV, what can we see? Can see that it obeys the AUF Bow principle because orbitals of lower energy are first filled. You can see that also it obeys the Hund's rule of maximum multiplicity since they are first filled 111. It doesn't obey the Pauli's exclusion principle. Pauli's exclusion principle. Because you can see that they are not opposite, right? It should be plus half minus half. So it doesn't obey Pauli's exclusion principle because Pauli's exclusion principle says that orbitals, no two electrons can have the same set of the four quantum numbers. So if it's like this, which one is plus half, which one is minus half? There should be a clear distinction. That's very good. So I hope everything is clear. Try questions like this. Ask questions in the comment field. So these are the conclusions we can make. It appears only I is correct because it obeys all the principles. Thank you very much for watching. Ask questions in the comment field.